All right, this is video 2 of your homework. This is now actually looking at the law of sines and using the law of sines to, I guess we'll call it solve a triangle. And it depends on your triangle. So if I come down here and you'll notice that you've got a triangle and 3 angles, A, B, and C. And it's important in law of sines to recognize that when we're talking about an angle, we need to be referencing the side across from that angle. So if this is angle A, then the side across from angle A is this little side A. Same angle B over across from it is side B. Angle C across from it is side C. When you took geometry, you probably learned a bit about these relationships, meaning if A were the largest angle, then side A would be the longest side. And if C were the smallest angle, side C would be the smallest side. So we're going to use this angle and side across from it when we talk about the law of sines. So we're going to come over here and we're going to do quickly a review of our area of a triangle. These are the formulas we were just using on the first video. The only difference is it's written 3 different ways. And the reason it's written 3 different ways is it doesn't matter which angle. You could have any one of those 3 angles, and as long as the 2 sides happen to be the sides that include that angle. So notice that in all 3 of these formulas that the angle A is not, the side A is not part of it. It's angle B, then side B isn't one of the sides. Angle C, then it's not side C. So these are the 2 sides that capture that angle. So for law of sines, again, I'm going to write several different equations because it doesn't matter which ones you use. You just have to have a pair of them to write a proportion. So you could know side A, and then we would be using the sine of angle A, the one across from it. And that has to be equal to side B in relation to sine of B. And that would also be equal to side C in relation or ratio with sine C. So when you do the law of sines, you would just have to have any 2 of these. You'd have to have 2 angles and a side, or 2 sides and 1 angle. It doesn't matter which one. But again, you're not going to set it up with all 3. You're just going to set it up with the 2 of them. So we are going to do an example. You might want to have that formula jotted down because it's going to help you. Let me scroll down here if I can. Again, this is not a formula you have to have memorized because it will be supplied for you on your exam formula sheet. So we're going to extend the page, and now over here I've got 48 degrees, and notice that 48 degrees is across from the missing value of x, and I have a 37-degree angle, and it is across from a side length of 23. So we could find this angle because all 3 angles in a triangle add up to 180, and once I know this side, I could also find this side, or actually because of the triangle sum theorem, I don't even need to do that. I could find out that angle and then find this side using the 23 and the 37. But we're only asked to find x at this point. We're not solving the entire triangle, which just means find every missing angle inside. So we're going to set up our ratio. We've got the side we know, which is 23. And I'll put that over top of the sine of the angle across from it, which is 37. And that has to be in proportion with the missing side, x, over the sine of 48. Now again, sides are on top, angles are on bottom. If you flip these, because of our laws of proportions, and put sine of 37 over 23 and put sine of 48 over x, you're going to get the same answer. Now if I want to find what x is, I got to multiply this sine of 48 away. So I'm going to come up here and I'm going to go, all right, I want to know what x is, so times sine 48. If I multiply the left side by sine 48, I have to multiply the right side by sine 48. I'm kind of jamming it up in here, but these will cancel. I will have x by itself. This, it goes in your calculator, making sure that you are in degrees and that the 48 and the 37 are captured in the sine functions. And once I do that, and with my calculator, I will get an answer of x equals, And if I did this correctly, I should have gotten 28.4 centimeters. And again, using some prior geometry, 48 is bigger than 37, so this side should be bigger than 23, and it is, so I feel pretty good about that. All right, so now we're going to come up here again, like we did on our other notes, and you are going to try this on your own, and you're going to check your answer. Again, we're good to go because the side that I'm missing is across from an angle I know. The side I have is across from an angle I know. So set up your proportion and solve. I'm going to pause the video. All right, I went a little too fast. This should be what you got for an answer from doing the 115. Again, I'll move this out of the way a little bit. A little bit tricky here with my solving for you. Don't even see my answer on here anywhere, which is interesting, so that's not a problem. If you did all the work, as shown here, you should have gotten x equals 13.4 centimeters. And again, that is across from the bigger angle, so it should be a bigger answer, and it is. All right, moving on. Again, this is a you try. And in reference to this one, notice that there's no picture. So I would highly recommend that you first draw yourself a triangle, label it AB. These are your angles. Notice this is a small b, so that is going to be your side length. It will be across from this. And you are trying to find side A, which is across from that angle. And this one will pose an extra little challenge for you. Maybe not on this one, actually. I lied. This one works out pretty well. All right, give it a go. Pause the video, try it, and then we'll check your answer. So pause. All right, this is my very poor drawing of a picture, labeled. Way too many colors in there. But again, you'll notice there's the setup with my proportion. I'm solving to get the side that I want by multiplying away a denominator, and you get an answer of 21.3 centimeters. So that again is the end of this video. Another nice short one for you. Hope that helped. Law of sines. You now know how to find the area using sine of any non-right triangle, and you know how to find missing angles or sides. We didn't try the missing angles, but we could if we know two sides and an angle, or two angles and a side, as long as they're across from each other. All right. Have a good evening.